I/O functions. This training will be divided in 4 parts. 1. Types of I/O. 2. I/O configuration. 3. Expand I/O. 4. NPN and PNP relay. The lecture time should be around 15 minutes and the objectives are the following. Know the pin definition of cabinet NT-IO. Know the I/O extension methods. Be able to use functional I/O. Know the common sensor wiring methods. Be able to deal with the NPN signal. Let's start. Types of I/O. Firstly, robot I/O types 2.1 cabinet has 16 channels digital input, 16 channels digital output. All of them are PNP type. Analog signals are multiplexed and can be selected as analog output or input port. As shown in the figure, under the label of the cabinet, its 2.1 panel DO and DI each serve as 16 internal ports of the cabinet. Terminals P1 and P3 are digital input ports for connecting input signals such as sensors and switch buttons. DI refers to the dry node input button on the wiring diagram. Connect one end of the dry node to the positive power terminal and the other end to the DI input button. P2, P4 specially refer to digital output port for output of signal or control of solenoid valves, indicators, etc. DO refers to the wiring diagram connect the positive terminal of the load to the negative terminal of the DO load to 0 volt. P5 terminals can be configured with 2 analog ports for collecting analog signal or controlling devices. P6 high-speed input interface for acquisition of high-speed encoder. Minicab I/O pins define input-output interfaces that are multiplexed by power interfaces. 485 master port, 485 slave port. Minicab as a record reuse I/O can be flexibly configured as input or output interface but are NPN type. Minicab has no analog signal. As shown in the figure on the right, the total number of digital quantity interfaces on the minicab is 7. And TIO at the end of the robot end flange. The TIO has 2 DI channels. 2 DO channels are NPN type. And one is AI input TIO pin definition at the end of the robot. As shown in the table, pin 1 is 24 volt. Pin 2 is DI1. Pin 3 is DI2. Pin 4 is DO1. Pin 5 is DO2. Pin 6 is AI plus. Pin 7 is AI minus. And pin 8 is the ground. I/O configuration method. Digital input interface can monitor the digital input status in a control cabinet. Click the digital I/O signal to change the name, select function settings, select the desired function for the DI in function selection. Click OK. When the DI signal is triggered, the function is enabled. I/O in the electric control cabinet window is the physical I/O in the robot electric control cabinet. I/O signal in a Modbus window refers to the I/O signal that is read from the Modbus address table after Modbus communication with external devices. Modbus window displays the I/O signal of the robot as a slave station. As shown in the picture on the right, click I/O to select the corresponding function. The functions supported by DI signal are shown in a table on the right. When there is a signal input, the DI indicator light corresponding to the control cabinet panel will light up. Each DI function needs different trigger conditions to distinguish the rising edge low level and the high level fault clearing function. DI can only clear collision alarms, but other abnormal alarms cannot be cleared. Reduction mode is to slow down the robot. The reduction rate of the second is less than the first. Reduction multiplier setting methods. Edit reduction mode multiplier in security settings and protection system parameter setting. To edit the reduction mode multiplier, make DI signal exit reduction mode first. How to make through I/O an electrical trigger so the robot can run with the default program. First, enter the program setting interface. Select the corresponding program in the default programs. Set up the completion by checking the three options. The robot loads the default program. After that, as long as the DI electrical signal is configured, the robot will automatically power on and enable, and then automatically run the default program. Note that when the default program is set up and the control cabinet is restarted, the program will be started at 100% of the global speed. DO signal supports functions. As shown in the table on the right, note that when there is signal output, the corresponding DO indicator light on the cabinet panel will light on. The idle states refers to the states in which the robot does not run programs and has nothing to do with the robot is powered on or enabled. The error status is that the robot triggered the collision alarm. Static states referred to the robot being at rest, such as program pause, program not running, program end, waiting for signal input. The moving state is different from the static state. Indicate that the robot is currently moving as long as the robot is moving, whether manually controlled or automatically runs the program. The electric control cabinet is on power on states and has nothing else to do with the robot body states. The reduction states of the robot indicate whether the robot triggers the reduction mode. The safety position signal is the DO signal output when the robot is in the initial position. The initial attitude can be modified in the robot attitude. How to trigger the robot to return to the initial position through DI and then DO signal. First of all, in the security setting, robot pause can be edited on the robot pause interface. Then, select one DI in the DI interface and return to the initial pause function. Select a DO function on the DO interface and select the position safe function. When the robot is in the initial position, in the safe position is set, DO will output this signal. Note that this function can be enabled without connecting DI to the initial location. Please refer to the JACA Hardware Introduction PowerPoint or JACA manual. Analog input-output interface can monitor analog signals. Click the analog input signal to select the signal function. Click the function selection drop-down window, select the corresponding function and click confirm to take effect. Currently, AI signals support the following function: voltage input, voltage output, current input and current output. In the analog signal interface, the analog signal in the Modbus window is the analog signal in the Modbus address table for Modbus communication between the robot and external devices. Analog signals at different positions in Modbus analog have different data types, based on the data type to select the analog signal type. Expand the I/O configuration. When the number of physical I/O in the cabinet is insufficient, you can expand the I/O module. TCP or Modbus RTU can be established between the module and the control cabinet through Modbus. For details about broken Modbus software, see Instruction to Modbus communication. There is a dynamic I/O configuration function in the I/O panel, so that the control cabinet can act as the Modbus master station. This function is located in the upper right corner of the I/O panel and has two states, running and editing. When you switch the editing mode, tap plus to configure the dynamic I/O. The configuration includes Modbus TCP and Modbus RTU. Modbus mode connects over Ethernet. RTU mode is connected through 485. Fill in the necessary information according to the blank step in the figure. Set the following parameters for Modbus RTU communication. The length verification mode must be the same as the slave node. After you click OK, the newly defined Modbus module and the usage of the NPN expansion card are displayed on the I/O monitoring screen. The NPN expansion board is an external expansion device added when the customer cannot use its own 16-channel I/O. The electrical attribute of the expansion board is the matching characteristics of the NPN robot. The first step is to connect Power Plus and Power Minus of the expansion I/O board to the 24-volt power supply. Connect the ports A and B to the 485A and 485B interfaces of the USB RS485 connection and use Modbus debugging software to configure parameters of the expansion I/O board. For details, please refer to the product manual. Start the Modbus POL software, insert the USB to RS485 converter cable into the PC. Click the connection menu, enter the connection setting interface, and connect according to the initial settings of the board description document. The fourth step is to configure related parameters according to the actual workstation situation. Step 5. Connect AB of the expansion I/O to 485A, 485B on the panel of the control cabinet. Step 6. Open a Jaka Zoo app to connect the robot. Click the lower triangle to enter the RTU control interface. Click the upper right corner to switch the operation to edit and click plus. Next, edit to enter the extending I/O editing interface. The seventh step, write the parameters of the expansion I/O board configured by Modbus POL software into the configuration information table. Click OK and switch the edit in the upper right corner to remote expansion board that can take effect immediately after running. 24 volt and 0 volt are connected with the V+ and V- of the board respectively. Connect the laptop to the network port of the board. You are advised to fix the IP address of the laptop to 192.168.1.37. You are also advised to change the unit ID to 1 and the Modbus RTU communication parameters to 9600 baud rate. 4. Confirm that the parameters are correct. Click the lower right corner to save and then restart the board. Last step, fill in the parameters of the board in the dynamic I/O configuration interface of the Jaka app and run it. This is the Minicab PNP expansion interface schematic diagram. You can also see on the table on the right the different signal and types for the minicab. For the minicab, RS485A and B are connected to the D+ and D- of the I/O expansion board. 24V plus and ground connect to the board V+ and V- respectively. NPN PNP relay. On the right, we can see the internal structure of a relay. The relay consists in 4 parts: coil, magnet, spring, and contact. The essence of relay is to use one circuit to control the on-off of another circuit. And the 2 circuits are generally isolated in this control process. The transfer contacts of a relay are 1 moving contact and 2 near contacts of the relay. The moving contact and the static contact 1 are in a closed state, which is called a normally closed contact. The moving contact is disconnected from the dynamic pulsation contact 2, which is called normally open contact. When the coil is energized, the moving contact is immediately disconnected from the feed contact 1, and the static contact 2 is closed to cut off the control line of the static control 1. And the control line of the static contact 2 is connected. When the coil loses power, the moving contact is reset. That is, the moving contact and the input contact 2 are reset and disconnected. And the static contact 1 is reset and closed, and the control line of the input and output point 2 is cut off, and the line of the static contact is connected. The diagram on the right is the physical picture of the combined and full relay. PA2 is the positive and negative pole of the coil respectively. When the contact of the coil is energized, the normal arm, the contact is disconnected, and the normally opened contact closes the wiring diagram of the control cabinet. Coil positive terminal is connected to the output high level. Coil negative terminal is connected to low level COM command contact. Since CAB 2.1 is effective as a PNP input high frequency, COM terminal is connected to 24V high frequency. If NPM type is needed, COM terminal step frequency normally open contact is connected to the second and acts as a signal input terminal. When the coil is switched on, DR8 receives a signal. That is all for this course. Thank you for watching.